Hey guys, Jake here, coming at you with another live math lesson this week. Today is October 17th, Monday. I do a weekly live stream every Monday night, 5 o'clock Pacific time. I will admit I did miss last week's live stream, and I know my YouTube channel has been a little bit quiet the last couple weeks. I've been quite busy with one-on-one tutoring, which I do. If you do want to get signed up for some one-on-one tutoring, you just want to kind of work with me in an isolated, one-on-one setting, you can definitely use the link in the description or in the pinned comment or pinned live stream comment, whatever you want. But yeah, you can go there and get signed up for some one-on-one tutoring with me, and we can go over whatever questions you have and help you out. But I do typically do these live streams every Monday night, 5 o'clock Pacific time, 8 o'clock Eastern, where we just kind of go over different problems, different topics. And as always, if you do have questions along the way as we go through these problems, just throw them in the live chat. I'm happy to help address whatever questions you have as we go through them. Even if you got some off-topic questions, throw them in there. I'll do my best to help you out. But I'm going to kind of continue on with some of the pre-calculus review that I've been doing recently, because I just want to make sure that everyone who is watching a lot of my calculus videos has that solid foundation of pre-calculus. To kind of build on that, and also so we can help kind of bring in some pre-calc students into the Jake's Math Lessons community as well. So today we're going to be talking about linear functions. We're going to be working with them, doing a few different types of things. Going to be talking a bit about different forms of linear functions, what they tell us about the line that they create, how to gather this information from the equation and how that looks on a graph. And then we're also going to do an example talking about finding parallel lines and perpendicular lines to a linear function, basically what that looks like, how to do that. So should be some useful topics, useful examples for you today. Let's go ahead and just jump on into the first example here, and we'll get started. So let me switch over to that view here. Here we go. So first question we're going to do is we're going to find the slope and y-intercept of the equation of the line. Then we're going to sketch the line. So this example here is it's given in a pretty convenient form, because what we have already been given, what the question told us right off the bat, obviously we're trying to find the slope and the y-intercept of the equation. And here's the equation we've been given. Well, fortunately, the form that this linear function is in already is the slope-intercept form. So the reason why it's called that is because the numbers that are in our equation are the slope and the intercept, the y-intercept of the line. So if you ever see a line or any equation that is in the form y equals mx plus b, where m, basically the number that you're multiplying by x, keep in mind, in this case, x is your variable, your input variable, y is your output variable, m and b are both constants, which basically means you want to treat m and b as numbers. In this case, they're kind of given by these generic letters that represent a number. But in this example here, you can see the number that's being multiplied by x is actually a number. And then this number that we have added on to the end here, that's not being multiplied by x, just some constant number, we also have a number. This right here is a 6, the number 6. This right here is the letter b. So just be kind of careful. I know a 6 and a b can look kind of similar, but just to kind of separate that there. But what we have already been given is a line that is already in the slope-intercept form. When you have a line in this form, the number that's being multiplied by m is always going to be your slope, or I'm sorry, the number that's being multiplied by x is going to be your slope. And then the number that's not being multiplied by x, basically just the number that is all by itself, the constant being added or subtracted on at the end, that's going to be your y-intercept. So in this case, just based on the form that this equation was given in, we already know that the slope of the line is -3 halves. And the y-intercept is +6. So if we were given an equation of a linear function, an equation of a line that was in maybe not this convenient slope-intercept form, we would want to algebraically kind of manipulate the equation to get it into this form, because once you get it into this form, it's as straightforward as saying the number that's being multiplied by x is your slope, and the number that's not being multiplied by x is your y-intercept. So just something to kind of keep in mind if you were given a little bit of a different form of an equation from the beginning. Now what we need to do is go ahead and sketch this line. So let's start out just by drawing some xy axes here. Actually, you know what? I'm going to do this a little bit bigger. So your x-axis is going to be your horizontal axis, your y is going to be your vertical axis. Then we just want to kind of number this, just add a few labels here. So 2, 4, 6, same thing on the y-axis. And then same thing over this way. Okay, so once we've got our xy axis drawn, we want to draw a line with a y-intercept of 6 and a slope of -3/2. So how do you do that? Typically, I think it's easiest to start with the y-intercept. So we're going to start with our y-intercept, which is 6. What that means is our line is going to intersect with the y-axis, this vertical axis, at +6, which is right here. So we know that we are going to have a point at 6 on the y-axis. So we know that we have to go through this point. Once you have your y-intercept point drawn, then you can start kind of figuring out some other points that your equation or your line goes through based on the slope. So a slope is always going to be rise over run. Okay. All that means is how many units you go up divided by how many units you go over to the right. So in this case, if we have -3/2, you want to basically think of your rise as -3. So you're going to go down 3 units instead of up 3 units for every 2 units you go over to the right. If your slope is ever negative, just make sure you're going down that many units and then to the right this many units instead of up this many units and then to the right. So think of your run as always counting units to the right, and your rise is going to be units up if it's positive, units down if it's negative. So we want to go down 3 units for every 2 units we go to the right. So basically what that means is we're just going to start at the one point we know. We're going to go down 3 units, 1, 2, 3, for every 2 units we go to the right. So then we're going to go 1, 2 to the right. So that puts us at x equals 2, y equals 3, because we went down 3 units from 6, gets us down to 3. And then over to the right, 2 units from 0 gets us to 2. Then we could just keep doing that over and over and keep getting a bunch of different points that lie on this line. So then we could go down from 3. We're going to go down 3 units because our slope is -3/2. So down 3, 1, 2, 3, which gets us down to 0. And then we're going to go over to the right 2 units. From 2 gets us to 3 and 4. So then we know we go right here. And then we could keep on doing that. So we'd go down to -3, over to 6, put this right about there. And then all we really have to do from that point is connect the dots. So I don't know. Let's see how well I can do this in a straight line. Might not look too pretty, but let's give it a shot here. It's not terrible, except for this little bend in line right here. But yeah, it should be a perfectly straight line if you can. So then we get something like this. So this is our line. Y equals -halves x plus 6. Because we had our y-intercept of 6, our slope of down 3 units over 2. Down 3 over 2, down 3 over 2. And we get something like that. So that's about it for that first example. I'm not seeing any questions in the live chat, so we will just keep things rolling here. Move on to the next example that we have here, which is this one. We're going to plot the points and find the slope of the line passing through the pair of points. So in this case, we have these 2 points, 2, 4, and 4, -4. So again, we're going to start by plotting these. I will just go ahead and start with our x, y axis again. Then we'll start by labeling our axes. Okay, so now we want to start by plotting our points. So to do that, you just want to keep in mind that any point is just an x-y pair. It's always going to say x first, then y second. So in this case, our x value is 2 and our y value is 4. So to do that, we just want to go basically start at the origin, start at 0, 0. First, to see where your x coordinate is on your x-axis. So our x coordinate is +2. So we're going to go over to x equals +2. And then we know that our point is going to have to be somewhere up above this point right here, this x equals 2. In this case, our y coordinate is 4. So we're going to go from this x equals 2, y equals 0, up to y equals 4. And that puts us right here. Okay, so that's our first point. 2, 4. Okay. Then we'll do our second point. So again, it's just an xy pair. So x is 4, y is -4. So we're just going to go over to x equals 4. So we're going to start at the origin, go over to x equals 4, +4, which is right here. So we know that our second point has to be directly above or directly below this dash mark right here. Then we're going to go down to y equals -4 from there. So we're going to go down 2, 3, 4. So that puts us right about here. Okay, so that's our second point. So now our line is just going to be a straight line basically that connects those 2 points. So we're just going to go from, actually let me label this one here real quick. Just like that. And then we need a straight line connecting those 2 points. That line might be slightly curved, but the idea is to get a perfectly straight line. Yeah, in fact, it definitely is curved a little bit. Let me try that one more time. Better, I think, but still not perfect. But I think you get the idea. We want a straight line connecting those 2 points, right? Okay, so once we've plotted the points, we need to find the slope of the line that passes through these 2 points. Well, we just drew our line that goes through those 2 points. We now need to find the slope of that line. Okay, so to find the slope of this line, all we have to do is think that slope equals rise over run. Okay, how many units do we go up or down? If it's up, it'll be a positive number. If it's down, it'll be a negative number, divided by however many units we go over to the right. So there's 2 ways we could do this. We could do this graphically or based on an equation. Since we did graph it, I'm going to suggest that we do it graphically first. I can definitely discuss how to do this with a formula in a moment. But to do it graphically, all we need to think about basically is how many units we go down divided by how many units we go over to the right to get from one of these points to the other point. Well, if we're starting way up here at y equals 4 and we're going down to y equals -4 to get to this point here, we're going to go down 1, 2, 3, 4, 5, 6, 7, 8 units. So from y equals 4 to y equals -4, we have to go down 8 units to get there. So our rise is going to be -8 because we have to go down 8 units. Remember, we always want to start from our leftmost point and go over to our rightmost point to figure out our rise and our run. Since we had to go down to get from our leftmost point to our rightmost point, our rise is going to be a negative number. Okay. Then once we go straight down to the y value that we need, -4, now we're going to go over to the right and see how many units right we have to go. Since we're at x equals 2 for this first point, and we need to go over to x equals 4, that means we're going over 2 units. So our run is going to be 2. So rise over run is -8 over 2. Then you just want to simplify it from there. -8 is divisible by 2. It would just simplify down to -4. So the slope of this line is going to be -4. And that's all it asks us to find, the slope of the line passing through those points. So that's going to be our answer, just -4. All right. Not seeing any questions in the live chat. So we'll keep on rolling here. We got one more question that I wanted to talk about. Okay. Write the slope-intercept forms of the equations of the lines through the given point, parallel to the given line, and perpendicular to the given line. So this is a two-part question. It's kind of weird wording here, but basically what we need to do is find the equation of the line. It has to be given in the slope-intercept form, the equation of the line that is parallel to the given line, and the equation of the line that is perpendicular to the given line, and it has to go through this point. Okay, so we're given two pieces of information. We are given a line, and we're given a point. We need to come up with two different line equations, two different parts to this problem. We'll talk about them separately. So let's start with part A. Okay, part A says we need to find a line that is parallel to the given line, and it has to go through this point. Okay, so if we're trying to write a line that is parallel to a line and goes through a specific point, there's a couple things we need to figure out. As with any equation of a line, there's really two parts to that: the slope and the y-intercept, or some other sort of information that tells you a point that your line goes through. You can kind of figure out the y-intercept once you know the slope and another point, because there's other forms that a line can be in, like, for example, the point slope form. Obviously, we need to get our line into the slope-intercept form, but we can actually start with a different form, and then we can kind of simplify or manipulate our line equation to get it into the slope-intercept form. So don't worry about the fact that we need the slope-intercept form yet. For now, let's just think about how to write a line equation that is parallel to this line and goes through this point. Okay. The way that you want to do that is to first figure out the slope of the line that we are dealing with. If we know that our line has to be parallel to this line, we first need to know the slope of this line so that we can then use that to find the slope of the line that we're trying to come up with. So to do that, what you want to do is get it into the slope-intercept form, or the slope slope form, and then you can use that to figure out what the slope is. So in this case, we have this in a form that's not particularly useful. What we can do, though, is manipulate this equation to get it into a form that is useful. That form would be the slope-intercept form. So to do that, you just want to get y equals mx plus b. So we just need y equals some number times x plus b. And this will tell you our slope. Whatever number is being multiplied by x, once it's in this form, will be the slope of this line. So in this case, to do that, all we have to do is subtract x from both sides, and we will move it over to the right side of our equation, and we would get y equals -x plus 7. Okay, so now we've got this in the slope-intercept form. We know that the slope of this line is -1, because -x is the same as -1x. So basically our slope is -1. And the y-intercept of the given line is 7. Okay, That does not mean that the y-intercept of the line we want is 7. It means the y-intercept of this line is 7. Okay, but we do know that the slope of this line is -1. This is important because the line that we're trying to come up with has to be parallel to this line. Well, what does it mean for two lines to be parallel? In order for two lines to be parallel and never intersect each other, they have to have the same slope. So we know already that the slope of our line has to be -1. So that's super helpful. Now we know we have to come up with a line equation which is parallel or has a slope of -1 and goes through the point -3, 2. Okay. So to do that, if we know a point and we know our slope, the easiest thing to do would be to use the point slope form of a line. The point slope form of a line is y equals m times x minus x0 plus y0, where you have a slope of m and goes through the point x0, y0. So basically we need an xy coordinate of a point that our line has to go through. In this case, we have it. It's -3, 2. And we need a slope of our line, which in this case we already have, is -1. So as long as our slope is -1, our m is -1, and then our point is -3, 2, which means that our x0 is -3 and our y0 is 2, we should be good. So we pretty much just have to plug those in. So doing that is going to give us y equals -1 times x minus x0 is -3. So keep in mind we have x minus -3. Be very careful about that. When your x coordinate is a negative, it's actually going to end up kind of doing the opposite here. And then plus y0, which is our y coordinate, which is 2. Okay. So now that we've written this in the slope point form, or the point slope form, depending on how you want to say it, we can rearrange this to get it into the slope-intercept form, which is the form that the question asks us to get it in. Okay. Before we continue on with that, though, I just want to make sure you're following along. If this makes sense so far, just drop a comment below that says, got it so far. And if you are getting some value out of this video, do me a favor and hit that like button while you're down there too. Okay. So now to rearrange this to the slope-intercept form, all that really means, that's kind of the most straightforward form to get a line into, because all you really have to do it is simplify your equation. Basically expand out, distribute throughout the parentheses, combine all your like terms, just generally simplify your equation. Okay. So to do that, we want to first start by simplifying what's inside the parentheses here. So we have y equals -1 times x minus -3. These two negative signs are just going to cancel out, and we're just going to get x plus 3, and then plus 2 outside the parentheses. Okay, then this -1 is going to distribute into the parentheses. We're going to get y equals -x minus 3 plus 2, and then the -3 and the plus 2 can combine, giving us y equals -x, -3 plus 2 is -1. So now our slope-intercept form is right here, y equals -x minus 1. So that tells us that our slope is -1 and our y-intercept is -1. And that is going to be a line that is parallel to this line and goes through this point. Okay. Now let's go on to part B. Part B says that we need a line that goes through this point and is perpendicular to this line. So we still have the same line and the same point, but now we know that it has to be perpendicular instead of parallel. So we're going to solve this very similarly to how we found the parallel line. However, our slope of the line that we're trying to create now is not going to be the same as the slope of this line, because if you make the slope the same, you're going to end up with a line that's parallel, not perpendicular. What do you need the slope of a perpendicular line to be? Well, it's not going to be the same, obviously. It's just going to be the negative reciprocal of it. What's a negative reciprocal? Well, to find it, you really just have to do two things. It's negative, so if your slope is negative, you have to make it positive. If it's positive, you have to make it negative. So we're going to multiply it by -1, basically. And a reciprocal is just flipping a fraction. So if you have a whole number like we have here, it basically means put 1 over that thing. If you have a fractional slope, like if our slope was a over b, the negative reciprocal would be negative b over a. You would just flip the fraction and then make it negative. If we had negative a over b, the negative reciprocal would be positive b over a. If you have a whole number slope, like our slope is m, the negative reciprocal would be negative 1 over m. So you would just make it negative and make it 1 over that slope. So in this case, we have a slope of negative 1. The negative reciprocal of that is going to be positive because this is negative, and then it's just going to be 1 over whatever that is. In this case, 1 over 1 is just 1. So the negative reciprocal of negative 1 is just positive 1. So we know that the slope of the line that we're trying to create in part B, the slope that is perpendicular to a slope of negative 1, is just positive 1. Okay, so now we know we need to make a line that has a slope of 1, and we still know that it has to go through the point negative 3, 2. So again, if you know the slope and you know the point, you can just use the point slope form of a line, which is just what we did in the last part. It's just going to be y equals mx minus x0 plus y0. So in this case, x0 is negative 3, y0 is 2, m, which is your slope, is 1. So you just pretty much have to plug those in for these 3 different pieces, minus negative 3 plus y0, which is 2. And then in order to get it into the slope-intercept form, like the problem asked us to find it in, we just have to expand this out and simplify. So first, x minus negative 3 is the same as x plus 3. So that'll be what's in the parentheses there. And then distribute the 1. 1 times x is just x. 1 times 3 is just 3. And then plus 2 outside the parentheses. And then combine your like terms. So x plus 3 plus 2, 3 plus 2 is 5. So x plus 5. So now this is going to be the line equation that is perpendicular to the given line and goes through the point that we needed it to go through. And it is in the slope-intercept form like the problem asked us to get it in. All right, I'm not seeing any questions in the live chat, so I'm glad to see everybody's getting it so far. If you did get some value out of this video, do me a huge favor and hit that like button down below. It's a huge help to my channel so I can keep getting these videos out to more people, keep growing the Jake's Math Lessons community, and keep helping you guys with videos like this. So if you, had a good time, be sure to come back next week. I do these weekly live streams every Monday night, 5 o'clock Pacific time, 8 o'clock Eastern. And if you're doing some tutoring between now and then, just use that link in the description or the pinned comment below, and you can get actually $40 off. That's my referral link for Wyzont, which is a tutoring website. And you can get a nice discount if you use that referral link. So go check that out if you're interested. And if not, I'll see you back next week. Thanks, and see you then.